In this video, we're going to look at the process for calculating a confidence interval for a mean in the case where the standard deviation for the population is known. Our step list is going to look pretty similar for all of our confidence intervals, with little changes to things like the distribution that we're using for our confidence interval and the structure of our standard error. So the very first thing you should do is define the parameter of interest in words. So in this case, the population mean that we're estimating. So you would write, for example, population mean mu equals mean height of all RSJ students. I want to know what I'm estimating before I start to estimate it. The next thing you'll do is identify the information given in the problem. And we know that we should keep an eye out for a couple of things. From our last video, we know that we need the sample statistic that matches the population parameter we're estimating. So I know I'm going to need an X bar. I need to know that sample mean. I know I need my sample size in order to calculate the standard error. I also need the population standard deviation for my standard error calculation. Those should be given in the word problem. And then I know that I need a confidence level. So I should label those with the values I was given in the problem. And you'll notice it says, if the mean was not given, you may need to calculate it. So sometimes you're going to be given a list of raw data and they'll ask you to calculate X bar. That's very rare in cases where the population standard deviation is known. It's more common when we don't know what sigma is. The next thing we're going to do is draw a standard normal curve, because we know that for cases where sigma is known, we're using standard normal. We're going to indicate the confidence level, and this should be centered in the picture. And then we're going to find the critical value. And to do this, I have a percentage. I want some boundary values. I'm going to use inverse norm on my calculator. Once I've done that, I'm going to use the formula to construct the confidence interval. And we know that it's the sample statistic plus or minus my z critical value times my standard error. And we know our standard error is the population standard deviation divided by the square root of the sample size. We can do that by hand, or we can use the TI-84, and I will show you how to do that in another video. Once we have our confidence interval, you'll notice there's going to be two values, one for the plus and one for the minus, and then we should state that result in context of the problem. So if we were estimating the mean height of all Rancho San Juan students, after I've done my confidence interval, my last step should be to write a sentence that says, we are 95% confident that the mean height of all Rancho San Juan students is between 62 and 65.8 inches tall. We're going to do a couple examples so you can see what this looks like in practice. So our first example says, suppose average pizza delivery times are normally distributed with an unknown population mean and a population standard deviation of 6 minutes. A random sample of 28 pizza delivery restaurants is taken and has a sample mean delivery time of 36 minutes. Find a 90% confidence interval estimate for the population mean delivery time. So they're asking me to build a 90% confidence interval for population mean delivery time. So I'm going to go through my 5 steps in order. The first is I'm defining my variable. So I know this is the mean pizza delivery time. And then the next thing I'm going to do is I'm going to list all of the information that I was given in the problem. So I'm told population standard deviation of 6 minutes. I'm told random sample of 28 pizzas and sample mean delivery time of 36 minutes. So let's list that in order. They gave us a sample mean of 36 minutes. They gave us a population standard deviation of 6 minutes. I know that I had a random sample of 28 pizza delivery restaurants. And I also know my confidence level was 90%. It told me I wanted to build a 90% confidence interval. The next thing I'm going to do is state what I'm going to do. So I'm being asked to build a z interval for the mean, and I know it's a z interval because I was given the population standard deviation. They specifically use that wording in the question. So I should draw a z distribution. Ooh, that was a little messy. So standard normal distribution, I'm labeling with z-scores. So -3 to 3, 0 is in the middle with our mean. And I want a 90% confidence level. So I need that 90% to be in the middle of the curve. And I know from the empirical rule that within 1 standard deviation is 68%. Within 2 standard deviations is about 95%. So 90% is probably just inside those 2 standard deviation markers. So I'm going to draw my lines here, just inside the boundary for 2. And this area here, I know is 90%, or 0.90. And I want the z values that go with it. And I know, because my curve is symmetric, I'm going to get a negative on the left, a positive on the right. And I also know to find those, I use inverse norm on my calculator. So for inverse norm, they're going to ask for an area. And in this case, I have 0.9. It's going to ask me for a mean and a standard deviation, and I'm going to leave it set to the default because I'm using the standard normal. And then it's going to ask me for a tail, and we want to use center. If you are using an older model calculator that does not give you an option for tail, it only gives you area, mean, standard deviation, in that case, if this guy's missing, you need to give the area in the left tail. And in that case, if 90% is in the middle, I know that leaves me with 10% for the tails, and half of that goes in each tail, so this would be 5%, or 0.05. So if I'm missing the tail command, I'm going to do 0.05 for my area, and it's going to give me just the lower bound. So let's go ahead and try that on our calculator. second vars inverse norm 0.9, 0, 1, and center, and then we go paste and run it. And you'll notice it gives us two values, negative and positive, but they're the same. We're going to ignore the sign. We really only want the absolute value of that result. So we know that our critical value is 1 point, and this is typically rounded to 645. Some books leave it as 1.64, but more commonly 1.645. From here, we're ready to grab that formula from earlier for our confidence interval. So we know our confidence interval is sample mean plus or minus critical value times standard error. So let's go ahead and substitute in our values. We know our sample mean is 36 minutes. We know our critical value is 1.645. We know that our population standard deviation is 6, and our sample size is 28. And that's going to give us two values. So let's go ahead and do the lower bound first. So 36 minus 1.645 times 6 divided by second square root 28. So I'm getting a lower bound of 34.1 minutes. And then to do the positive, I'm just going to go highlight that and change the subtraction to addition. And we get 37.9 minutes. So I can now state that the population mean delivery time is between 34.1 and 37.9 minutes. So we are 90% confident that the mean delivery time is between 34.1 and 37.9 minutes. Before I move on, you'll notice our sample mean was 36, and 36 sits exactly halfway between those two. If I go up, that's plus 1.9. If I go down, that's minus 1.9. So our interval should be symmetric about our point estimate, because we are adding and subtracting the same value, that margin of error in both directions. Let's do another one really quick, and then we'll go ahead and wrap up this video. So this example says a random sample of 50 cars in the drive-thru of a popular fast food restaurant revealed an average bill of 18.21 per car. The population standard deviation is 5.92. Estimate the mean bill for all cars from the drive-thru with 98% confidence. You'll notice the wording's a little different. The only direction they give us is estimate. The reason I know that I'm estimating with a confidence interval is they gave me a confidence level. So even though the wording's a little different, they are asking the same thing. I'm estimating the mean bill. So this is an estimate for a mean. And at some point I saw the words population standard deviation. So this is very similar to the last example in that we're estimating a mean and we know sigma. So our mean is, using words from the problem, the mean bill for all cars from the drive-thru. I was told I have a random sample of 50 cars. I have an average bill from that sample of $18.21. I know my population standard deviation is 592, and my confidence level is 98. Again, I have sigma, I'm estimating mu, so this is a z interval for a mean. So we draw our z interval, our standard normal. We mark our confidence level, in this case 98%. I know 95 is within 2, 99.7 is within 3, so I'm sitting somewhere between 2 and 3. So this area here should be 98%. Or 0.98. To find those critical values, we're going to go ahead and use inverse norm on our calculator. So area is 0.98. Mean is 0. Standard deviation is 1. And then tail is center. Just like last time, if you are using an older model calculator and you don't have the choice of tail, yours cuts off here, you need to find the area in the left tail. If there's 98% in the middle, that's 2% left over, which means half here and half here. Your area would be 1% down here. For us, we get our critical value as 2.33 rounded. And now that I know my critical value, I'm ready to build my confidence interval. So sample statistic plus or minus critical value times standard error. So in this case, our sample mean was 1821. Critical value was 2.33. Our population standard deviation was 592. And our sample size was 50. So for a lower bound, I'm getting 16.3. Well, let's go out to, let's see. Our original data was 2 decimal places out, so let's go 2 decimal places out to 6. 6. We know that's in dollars, and then we'll use that same trick. We'll go up, change the subtraction to addition, and we get 20.16. So for our sentence, we are 98% confident that the mean bill for all cars is between $16.26 and $20.16. So that's how we calculate our confidence intervals by hand for a mean when the population is known. In our next video, we'll take a look at what this process looks like when we don't know this population standard deviation. But the procedure that we're going through should feel very familiar. You're going to notice a pattern of defining variables, stating what we're given, drawing our distribution, calculating our critical value, finding the confidence interval, and then writing a sentence. We're going to use those same 5 steps over and over and over again. If you have a question about what you just saw, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.